K 2017 set 1 electrical question number 5. So it is given that consider an electron, a neutron and a proton initially at rest and placed along a straight line such that the neutron is exactly at the center and of the line joining the electron and proton. At time equal to 0, the particles are released but are constrained to move along the same straight line. That means initially they were held by some external means, and at time equal to 0 they were released. So as you can understand, there will be a electric force working between the charged particles, and the question is asked that which one of these will collide first. So these are the options given. The particles will never collide, all will collide together, proton and neutron, electron and neutron. So I have to first analyze the situation, what they are trying to tell. So what it is telling is an electron, neutron, proton was initially at rest and placed along straight line, and neutron was exactly at the center of the electron and proton. Okay, so first to solve this problem we have to see some useful data. So you see, protons are positively charged, so I'm writing here protons are positively charged, neutrons are zero charged, and electrons are negatively charged. As you can see, relative charge is +1, neutrons are neutral, and electrons are having negative charge. Now the point to note here is the mass of a proton is 1.6 into 10 to the power minus 27, and the mass of neutron is also 1.6 into 10 to the power minus 27. So these are the equal masses of proton and neutron. Electrons, whereas, are having a much lesser mass. It is 10 to the power minus 4 times less, as you can see. So it is very much lesser in mass compared to that of proton and neutron. It is 9.11 10 to the power minus 31. So from this we can analyze, and we can finally come to the conclusion that mass of electron is much less than that of proton and neutron. Also, you know that force is mass into acceleration given by Newton's law, and acceleration comes out to be force divided by mass. So also Coulombs law says that when two like charged particles are separated by some distance, say for example this is r, and then they are under the influence of some electric force which act between those two particles. Similarly, like and unlike, there is a plus and a minus, their force of attraction is there, and if two like particles plus or minus are held together, then a force of repulsion acts between the two, and both this force on this particle or this particle are equal in magnitude but acts in the direction respective to the relative charge they are in interaction with. So you can see in the magnitude of this force is k q1 q2 by r square, where k is Coulomb's constant, which is equal to 1 by 4 pi epsilon naught. So to the solution, this is the exact situation that is told in the question. The neutron is placed exactly at the center of the line joining the electron and the proton, and at t equal to 0 they are released. Now once they are released from some external means that was used to hold them together earlier, now a force that was acting between them will come into action. So what will happen? Electron and proton will attract each other by some force, electric force. Let this be Fe. So both will be under the influence of the same force. This force will be of equal magnitude, and this force will act on both the electrons and the proton. Now as you can see, force magnitude is given by, this is E and this is E, magnitude of mass, so E square by 4 pi epsilon naught r square if the distance between electron and proton is r. Now force is also equal to mass into acceleration. Now if mass increases, then acceleration should decrease if force is constant. Implies acceleration of electron is much more than acceleration of proton. Agreed or not? Why? Because mass of proton is much more than mass of electron. Now since mass of proton is much more than mass of electron, so acceleration should decrease because force acting on both proton and electron are same. So mass of proton is more, hence acceleration of proton should be less. Now since acceleration of proton is less and acceleration of electron is more, so for the same given time they were released. So in the electron, in order to cover this much distance, let's say this distance is r by 2 and this distance is also r by 2, so we know s, that is distance, equal to u plus at, where s equal to distance, a equal to acceleration, and t equal to time. Now the distance between electron and neutron and proton and neutron both are same, so s is distance is constant. U is 0 because they were initially at rest. Now we see more is the acceleration, less is the time required. So since acceleration of electron is more than acceleration of proton, so time taken by E is much less than time taken by proton to collide with neutron. Hence the answer will be which of these will collide first with the neutron. So the electron will collide first with the neutron. So this will be the answer. Thank you.